Hey guys, how are we doing? So in this video, we're going to go over the law of conservation of energy, a really important law in physics. And one that's actually really easy and really nice, but people always forget about it and then get stumped in the maths. Okay, so we're going to practice that today. We're going to go over what it is and then look at an exam question. Okay, these exam questions are normally around 6 to 7 marks, depending on how generous they're being. Okay, so if you like the video, remember to hit subscribe. And remember, you can always get that extra revision resources on my resources. And if you want to join our live lessons, which would be awesome, just click the link in the description. So, conservation of energy, what is it? Super important law of conservation of energy is that energy cannot be created or destroyed it can only be transferred from one form to another. Or if you don't like the word transferred, maybe like me, you're terrible at spelling, you can just change it to can only be changed. Okay, so whatever you like. So energy cannot be created or destroyed, only transferred, only changed from one form to another. So what that means is, if I know that my car, for example, is moving, and my car, when it's moving, I know that my car has kinetic energy, right? So my car, again, it's moving along. Because it's moving, I know that it has kinetic energy. But that energy has to come from somewhere. So you think, where did that car get the energy from, right? It can't just have free energy. It can't just create that kinetic energy. Because it had to come from somewhere else. It had to be changed somewhere else. Or if you're thinking, in my car, I know I can't get my car to start unless I have fuel inside it, unless I have petrol. Right? Your parents probably think, oh, right, the petrol's going out, and you just get stressed, the car might stop. Because the car can't keep moving, it can't keep having kinetic energy if there's no fuel in there. Because in that fuel, hope you're thinking we know fuel has that chemical energy. So chemical energy inside the fuel gets transferred, it gets changed to that kinetic energy so that my car can move. Okay, so again, chemical energy is in our food or fuel. Same thing today, right? I'm walking around, I'm talking, I'm blinking, my heart is beating. I have loads of kinetic energy, and I have that kinetic energy because I had breakfast, right? Because I had lunch. I can eat food, and I get that chemical energy from that food inside my body. I put that energy in my body so I can use it in other ways. I can use it as kinetic energy to move. I can use it as thermal energy to keep me warm. So, how does this come up in questions? So it says, a question could be, let's say we've got a roller coaster. I want to know what is the speed of the roller coaster at the bottom. Hopefully you're thinking, if we have these two roller coasters and I go to the ride, maybe I go to like Fort Park, hopefully you're thinking, I definitely want to go on this ride, right? This ride is going to be more fun because I know straight away that it's going to be faster at the bottom. And you know that it's faster at the bottom because you know that it's higher up to begin with. Because you already learned this, right? You learned this without meaning to. That things that are really high up to begin with can always go faster at the bottom. So why is that? Why can things that are high up go fast at the bottom? For example, this would be a kid's ride, right? No one wants to go on that. So things that are high up, why can they go fast at the bottom? Because the higher you are above the surface of the earth, the more gravitational potential energy you have. So when I'm really high up here, I have loads of gravitational potential energy. And I know that all of that gravitational potential energy, as I go closer and closer to the center of the earth, it decreases, 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 because where does it go? Right? Where does that energy go? It goes into kinetic energy because I'm moving. So all that gravitational potential energy goes into my kinetic energy because I'm moving, right? I start to go really fast. So what we say is that all of the gravitational potential energy is going to go into my kinetic energy. And that's why I can go really fast at the bottom. So we're thinking, how do we know how much gravitational potential energy we have? So I'm thinking, if I'm this height above the ground, how do I calculate how much gravitational potential energy I have? And I know, either from looking at my formula sheet or I remembered it, that gravitational potential energy is mighty God in heaven, mgh. So I can calculate how much gravitational potential energy we have right here at that height above the earth. And we know it's all going to get our kinetic energy, and we know we can calculate our kinetic energy because we know that rhyme, that eating half of my vegetables twice. Again, shout out year 10 homeschool. So energy is a half of the mass times the speed squared. Now the whole point of this is when I find what the speed is, right? The whole point is I want to find what the speed is. But right now, I can't just find the speed, because if I try to plug this in, nowhere was I told the energy. So nowhere do we know what the kinetic energy is to be able to calculate a half times the mass. We do know the mass. The mass of the person in the ride is 300 kilograms times by the speed squared. Do you see? So I can't figure anything out right now. I don't know the energy, so I can't figure out the speed. So that's why we had to think, how did we get the energy? How do we know how much kinetic energy they have? And again, we know how much kinetic energy they have because we assume that all of the gravitational potential energy goes into the kinetic energy. So that's why we're going to figure out first, what is that energy? What is that gravitational potential energy? So gravitational potential energy is my mass, which the mass was 300 kilograms, times by g. And it says somewhere on your page what to use for g. So somewhere on my page it says what to use for g, and up here it says what to use for g. We're going to use g as 9.8 times by the height. So what is the height of this roller coaster? Heights or distances in physics are measured in meters. So that's my 50. So all we do now is we plug those numbers into our calculator. So in our calculator, we're going to do 300 multiplied by 9.8 multiplied by 50. We get a number of 147,000 joules, because energy is always measured in joules. So that's how much gravitational potential energy we have right here at the top. But we know all of that gravitational potential energy goes into kinetic, so now we know what our kinetic energy is. Our kinetic energy is 147,000. That kinetic energy, again, we said equals a half times the mass times the speed squared. So hope you're thinking, how to do this? Some of your teachers might be like, use equation triangles, but we're not going to do that because we all want to do A-level physics. We're going to get good at rearranging equations. So we're going to simplify it, right? It's actually quite easy to do. It's nice to do. We're going to be perfect at it. So simplify it. Let's get rid of this. So what we're going to do is 147,000. A half of 300 is 150 times by v squared. Now I just want v squared by itself. So you're thinking, how do I get v squared by itself? How do we get rid of this multiplied by 150? You're thinking the opposite of multiply is divide. So what we do to one side, we do to the other. So what we're doing in our calculator is 147,000 divided by 150. We divide it by 150, I get 980 is v squared. But you're not finished, right? That's v squared. You need v. So to get v, go to the opposite. Now that's v squared. How do I get what v is? Well, we're thinking the opposite of squaring is square rooting. And what we do to one side, we do the other. So what I go do is square root of that answer, of that 980, to get my final answer for my speed. And my speed then comes out at 31.30 meters per second, because speed is always measured in meters per second. So to recap what we did, and remember, we're always going to recap because we want to make sure we didn't make a mistake. We type things in our calculator. So first thing we did was we realized we're trying to find speed. If anything is moving, I know it's called kinetic energy. Kinetic energy is a half the mass times the speed squared. Kinetic energy is a half, 0.5, times the mass, we were told was 300, times the speed squared. We don't know what the energy is, so I can't find the speed yet. So you had to think, how do I know how much energy it has at the bottom of this ride? You should be thinking, I know that all of that kinetic energy came because my ride started really high up. It had loads of gravitational potential energy. Remember, the higher you are above the surface of the Earth, the more gravitational potential energy you have. We can look at our formula sheets, or we can remember that gravitational potential energy is mighty God in heaven, mgh. The mass of our ride is 300 times g, it told us to use 9.8, times the height that we are above the surface of the Earth is 50. So what we did was our 300 multiplied by 9.8 multiplied by 50, and we got 147,000 joules. Now all of that gravitational potential energy goes into my kinetic energy. So kinetic energy is a half of the mass times the speed squared. This is a little bit hard, so we simplified. We did a half of 300 to get 150, times by v squared, and we kept the numbers still the same. Now I want to get v squared by itself, so the opposite of multiplying by 150 is divide by 150. We'll do the one side, we'll do the other. So what we did was 147,000 divided by 150 to get 980. 980 is v squared. Remember, to get v, we do the opposite of squaring, which is square rooting. We do one side, we do the other. So we did 980 square rooted, and we get 31.30 meters per second. So that's how fast someone's going at the bottom of that roller coaster. So hopefully you find this video. Just remember to like and subscribe if you did to get more.